Morning, good afternoon, good evening to everybody on the call. So just a little bit of sort of thanking my sponsors, I suppose, in a way. This work has been sponsored variously throughout its life cycle, and probably we've been working on artificial light in the marine environment now for about 10 years. We started off with a small grant from National Geographic. Then we got some money from the UK Research and Innovation Council, the Natural Environment Research Council, and we've recently won some money from the European Commission as part of the Aquaplan project, which is looking at the juxtaposition of artificial light pollution and also anthropogenic noise in the marine environment. So if artificial light wasn't enough of a difficult problem to pin down and quantify, we're also looking at where light and noise come together. So today I'm going to speak to you about the impacts of artificial light pollution, or ALAN, on marine biodiversity. There's been a lot of people who've been involved in this work. So myself and Tom Davies from the University of Plymouth have been working on this project or this problem now for about the last 10 years together. I'd also like to mention Jenny Lockett, who's been pushing forward a lot of the impact of this work, and then some of the web browser type technologies has been pushed forward by Ben O'Driscoll. And then we've also been getting into the socioeconomic consequences of our work. So I think it's fair to say, and judging by the number of people who are on this call, so it stands at 146 at the moment, 147, there's an increasing awareness of artificial light pollution as a problem. So all of you will be aware of this type of plot, and this was produced by Chris Kyber, who many of you will know. This appeared in the journal Science a couple of years ago now, and was covered by a lot of the major news outlets. This was just taken from the BBC News website, because it seems to be that we get quite a lot of coverage now in the UK from this particular topic, where you can see the range of the Bortle scale all the way through from 1, which will be the excellent dark skies, all the way through dark rural suburbs, and then till you're in the city where you've got this kind of bronze or white dome of sky glow, completely obscuring what should be the beautiful night sky. And there's been also several popular science articles. This one grabbed my attention last year in the conversation. So Orgro was writing about how light pollution has cut humanity's ancient connection with the stars, but actually a message of hope as well, how we can restore it. And actually, I think this is one of the great things about artificial light pollution as a challenge. It's actually much more tractable, I think, to be able to address as opposed to something like climate change, which is much more difficult to solve as a problem. So he gave in his, or they gave in their article, this wonderful image of what the constellation of Orion should look like, and this is what most of us see in our towns and cities, or even worse than this, in actual fact. And then it's not just about how it kind of has maybe severed us from our connection with the night sky in terms of spiritual ways, but also it's possibly harming our bodies as well. So there was another article, this time in the Washington Post, by Paul Bogart on it actually doesn't have to be this way. We can do something about this. So now looking at sort of the more the popular science type articles, this was a book written by Geoffrey West. His book on scale is really worth looking up. And one of the things that he says in his book is, he says, we've had this sharp transition out of the purely Anthropocene. So many of you will be aware of this term called the Anthropocene, which is about how human beings have had an impact upon the environment or the climate. And what he says now, we've exited the Anthropocene and now we've entered another epoch, and he has coined the term the Urbanocene, which I really like as a phrase or as a term. And his evidence for saying that we've entered the Urbanocene was this image he put in his book, was this image of from the International Space Station, clearly showing the coastal light pollution on the Iberian Peninsula. So just imagine if you were on an imaginary International Space Station 50 or 100 years ago, you just wouldn't have seen anything like this. So this is a very clear marker of from space on the dark side of the Earth of our impact upon the environment and upon the way that the Earth looks from space. So now changing tack slightly. So most of what I've already said, all of you will be very aware of and be very excised about. But now I'd like to look at the subject of marine artificial light at night in the marine environment. So how widespread is it to start with? And I'd like to start by sort of describing what we really mean by artificial light at night in the marine environment. So this is a schematic here showing the different pathways of light into, let me just give myself a little laser pointer here. So what you can see here are the different pathways by which light takes before it enters the ocean. So this will be from direct lighting. So this is quite near field effects. So you only need to go maybe 50 to 100 yards away from a light before you stop really getting much impact of the individual light into the water. But underneath the light, you do get a large impact from the lighting. But this is the thing that we're majorly concerned about with the artificial light pollution in the marine environment. It's these pathways here, either where you've scattered, you've shone light up into the atmosphere, and then it's reflected down by molecular scattering in the atmosphere, and then that enters the marine environment, or you get scattering by clouds, and then that enters into the marine environment as well. So the starting point for our work is a publication that many of you will be aware of now. So this was this is a work by Fabio Falci and co-authors, and this was published almost 10 years ago now. And this was where the New World Atlas of Artificial Sky Night Brightness gave us our source term. And if you look at his atlas, you can see very clearly where you've got the very light polluted areas. So Europe really springs out. So the eastern US is really heavily light polluted, and sort of the Middle East is pretty impacted by artificial light pollution. You can see all the other areas of the globe as well. So that's our starting point for looking at artificial light pollution in the marine environment. That's where we can see how much light there is available, likely to be scattered down to the ground level and into the ocean. Sorry for the detail here, but I thought what this enables us to do, it really shows where how we actually model light within the water. So what we use is we've got an in-water optical model, which relies upon different constituents in the water, either absorbing or scattering within the water. So we've got an in-water optical model. I've already mentioned the above water artificial light from the Fauci Atlas. And then what we've coined is this term we've said is the critical depth. So what we're looking at here is the light that is detectable or visually detectable by Calanus, which is a zooplankton in the marine environment. Now, Calanus are incredibly low light adapted. They can see light at intensities down to 0.1 microwatt per square meter. And I'll give you a little bit of context now as to what that actually means. So this critical depth here. So on a bright sunny day, you're getting around a few hundred watts per square meter on a clear sunny day. So that's a clear sunny day. And then what you get when you've got a nice full moon. So last night was the harvest moon, and generally on a full moon you're getting around 1 milliwatt per square meter. Twilight is about 1 milliwatt to about a watt. So what we're looking at here is about 9 orders of magnitude less than what we would see at the surface. So that gives you an idea. So 1 billion times less of what is usually seen during the daytime. And what we found so this is taken now directly from our marine artificial light maps. What we found is that globally, around about 22% of coastlines are impacted by artificial light at night. And that equates to an area about 10 times the size of the United Kingdom. So it's quite a large area. It's about 2 million square kilometers. Okay, so that's something about the extent of artificial light at night in the marine environment, but actually, does it really matter? You know, it impacts us in terms of, yes, we can't see the night sky anymore, but actually, does it really matter to marine organisms? And I think the answer I hope you'll take away from my presentation in a moment is emphatically yes. And we're uncovering new impacts all of the time. So a few years ago now, we had a review article in Global Change Biology, where we looked at all the impacts, all the documented impacts within the marine environment. So we gave evidence there of all the scientifically proven impacts upon different parts of the marine ecosystem. So just to sort of pan out from these two schematics that we gave in our presentation. So this is what we would like to see on a pristine dark skies night. Maybe we've got the moon in the sky, so it's not that great for astronomy, but you know, this is what we would aim for where we've got a natural state. I'd like to highlight here. So this is coral. So we've schematically shown the coral ecosystem here, and you can see the coral spawning here. You can see also the zooplankton in the water. So generally what happens at night, so the daily vertical migration, so the daily vertical migration of zooplankton is such that during the daytime, they go down to great depths, maybe 200-300 meters in the water column to escape predators. And then during the night, they migrate up to the surface. This is the largest migration on the planet. So think about the wildebeest in the savannah in Africa. This is the marine equivalent, but on a much bigger scale in terms of biomass. So this is what's happening here. And then you can see seabirds flying around, not being particularly attracted to any light source. You can see the fish in the sea. You may be able to see the turtle hatchlings heading in the right direction out to sea, sandhoppers, this kind of thing. And then what happens when you start introducing light into the marine environment? Straight away, you see aggregations of fish. Now, I know this from research cruises we've carried out in the very deep middle of the Atlantic Ocean. And almost immediately, as soon as you put your ship lights on, you get this aggregation of fish, of squid, etc., etc. So they're very much drawn to the lights of the ship. What happens with the zooplankton? We've got evidence from the literature that zooplankton go down to great depth again to avoid the surface light. Seabirds aggregate around the light, so around the oil platforms, around the fishing vessels, around the buildings at the seashore. And you can see also that this coral broadcast spawning is no longer occurring at the right time and in the right way. And then you can see the turtle hatchlings finally being completely disorientated by the artificial light pollution and going in the wrong direction. So we have evidence now and growing body of evidence with as each year goes by as to the impacts upon the marine environment. So it's not just about light intensity, but also color really matters in the marine environment. So here's a statistic here. So in terms of the way that we're changing, certainly in Europe, and it's probably the same in the US as well, and throughout the world is that we're expecting that 85% of our street lighting by 2028 will be LEDs. We're doing this for all the right reasons, for energy efficiency, but the difference in the lighting or the quality of the lighting is very, very different indeed. So this is what most of us growing up would have seen in our urban night skies. We would have very much seen the orange glow from the sodium lights above our cities, giving a much more orange glow in the sky towards a much more white, bright, broadband. The problem with this is that this broad spectrum and this blue peak within the spectrum coincides with many, many biological responses. And particularly in the marine environment, blue light penetrates much deeper within the water column. So when you've got a lot of orange light, much of the light is already cut out by the natural absorption of water and also the constituents in the water. Generally, you don't get much red light down below 2 to 3 meters in the water column. But what you find with blue light is that it can penetrate, particularly where you've got very, very clear waters. So thinking where you've got very light, bright city lights very close to the coastline and very clear waters. So think the Mediterranean, for example. You're getting much, much more light penetration because of the shift in the spectrum of the light. We're also finding, so we had a publication a year or so ago now, where we looked at how the change in the spectrum has compromised the different predator-prey relationships and the different strategies of camouflage. So we were looking at littorinid snails in this particular study, and we found that they were much more camouflaged with the old style lighting than they are with new. Now, this is good news for carcinus, so shore crabs, because they can actually see the things that they want to eat much more easy, but it's not so great for the littorinid snails. The other thing is that there are different intensities of light which stimulate biological response in different types of creatures. So mammalian creatures can have got a relatively low, they need quite high light intensities to be able to see. Whereas when you go down from through avian, through reptiles, through to insects and arachnids, they've got a much, much lower intensity of light that they can respond to. And then what you can see is here with our LEDs. So we're going from 350. So this is in the UV through into the blue end of the spectrum, into the orange and into the red. These LEDs are giving a response right across the spectrum here. And this is very important for lots of different biological responses and color guided behaviors. So that's something about, so we've talked about the intensity of artificial light at night, and we've talked about the color of artificial light at night being important for marine biodiversity, but also rhythms matter in terms of light. So what do I really mean about that? And one way that we've looked at this in a recent publication we've had is that we've looked at a lot of the megacities. And megacities, and what do we mean by megacity? A megacity is where you've got a population of more than 10 million. So in our publication, we looked at LA, we looked at New York, we looked at Buenos Aires, Lagos, Mumbai, Shanghai, and Tokyo in our study. And just for, it's not a mega city, but just because we live here and we've done a lot of research on it, we've done we've looked at Plymouth in the United Kingdom. So that's just give an idea of the populations of these different countries. So in terms of top trumps, sort of Tokyo comes out with a population of 37 million, and LA and New York, as you would know, is about 12 or 19 million. So then what we did in this study is that we looked at the intercomparison between natural light cycles and so artificial light at night intensities. So what do we mean by the natural light cycles? We looked at lunar and twilight, and then we looked at the rhythmic qualities of these different light sources. So we looked at tidal, and also the lunar phase impacts upon the lighting. And then it was essential that we included the spectral component, as I've already said. Sorry that this is a little bit of a complicated plot, but I'll walk you through it. So this is the kind of response that you would expect from the sun rising in the morning and setting at night. And our nighttime is this kind of Venetian blind effect of on-off, I suppose. So you can see that it's a very sinusoidal response when it comes to the sun. And obviously there's a large range. So this is a logarithmic scale now in terms of watts per square meter. So this is the sun. And then you can see now we've shifted it in terms of scale. So this is in microwatts per square meter. So much, much less. So this is a factor of, sorry, this is 6 orders of magnitude, typically less than the sun. And you can see as you go through the lunar cycle with the moon rising successively later nights, and this is when you get to the full moon. This is how it looks in terms of its kind of sinusoidal, very natural rhythm to the light, and then you get the sort of the increase as you get the waxing moon, and then the decrease with the waning moon. So then you get, and then you compare this with the rhythm that you get with artificial light at night. It's very much an on-off top hat type function. So as soon as the sun goes down, you've got maximum artificial light at night irradiance, and then it's at the same intensity all the way through the night until the lights go off again. So that's what we've assumed for this particular thing. And you can see just at a glance there, the different rhythms that there are in the system. So these are very natural rhythms that we're getting here from the moon and the sun, and these are very unnatural rhythms that we're getting with artificial light at night. And I've also color coded this. This is blue light and this is green light, just to give you an idea. We also superimposed the effects of the tide. So we had a different depth of water column at the given cities. And then we were able to then modulate our signal. So this is the moon now modulated. I think if I go to the next slide here, you can see the difference between the signals then when you modulate those signals with the natural signal. So what do we find overall? So what we found in terms of the exposure of artificial light at night, we found that over a monthly cycle, that artificial light exceeded the lunar component by up to a factor of 2.5. So we're getting much more energy into the system now than you would get from the major natural source. And then we also found that lunar always exceeded or lunars was always exceeding artificial light at night on the full moon. But actually at other parts of the month, then obviously that effect from the moon was much reduced. So now shifting attention to the impact of the artificial light at night on coral broadcast spawning. So this was a publication we had published last year. So this was led by Tom Davies and published in Nature Communications in April 2023. And what we found here, or what we did here, was we looked at several different types of coral. So these are the different species of coral that we looked at. And we looked at areas of the globe. So this is the Red Sea here. We looked at where these different coral populations, so this is in near Eilat in Israel, and then we're looking down the Saudi coast here at different coral populations here, and where you can see the bright colors, that's where you're getting a lot of artificial light pollution. So what we did was that we compared populations of coral in areas we had a lot of artificial light pollution, and we compared it with where we've got very little. So this is in these areas here in Southeast Asia. You can see that there are some areas which, say off the coast of Borneo, that have very little in the way of artificial light at night pollution, and then off the eastern seaboard of Australia. So we had a good sort of range of populations. And what we found here is that the cue that the the coral are looking for in terms of the lunar cycle is that they wait for the full moon rise after the end of twilight. So it's not right on the full moon, it's a couple of days or 3 days shifted afterwards. And they're actually looking for this period. So this is where you've got the full moon here. So you've got moonrise at sunset and moonset at sunrise. And what you find is that in where you've got this period of darkness just after sunset and before moonrise, they're looking for that dark potential well. And what actually is happening is where you've got lots of artificial light pollution is that you're actually filling that well in. So they're unable to look for the cues that they've always been looking for. So finally, I'd like to say to look at some of the impact work that we've been able to we've been doing, and sort of throw the question out to you guys, and we can have this discussion now. So, what can we do to reduce the impact of light pollution on the marine environment? So, we've been taking this strategy recently. So, first of all, I think is we want to increase the awareness of artificial light at night impacts and also the solutions. What we would want to do is that we want to target the biggest contributors and look at the most sensitive habitats and species. And we want to work with regulators and industry. So we've been having some success in this area, particularly with stakeholders who are concerned with the state of the marine environment. But we want to work with them more in terms of supporting action in getting things like the spectrum of the light changed, the amount of photons that we put into the environment, these type of ways of addressing it. We also would want to see policy implemented that ensures the legal duty to address light pollution. So looking at how new build developments are required to minimize the impact of lighting infrastructure. And also, and this is important here, is recognize marine impacts alongside the terrestrial ones. Now, terrestrial ones have been understood and recognized for maybe 20, 30 years, whereas marine impacts are really coming, climbing up the agenda. And we want to be able to recognize on an equal footing the marine and the terrestrial environments in current legislation. And then also we want to create conservation measures to protect sensitive habitats and species. So marine protected areas to include artificial light at night restrictions, and then this concept of dark sky reserves for marine areas as well. And ultimately, we need to reduce light pollution to minimize the impacts. So how do we sort of develop this concept of a dark sky reserve in the marine environment? So one of the tools that we've been developing is a portal for our global atlas of artificial light at night under the sea. So if you actually scan this QR code in using your smartphone, that should take you to this portal here, and then you can start playing around with the data. I think one of the great things about web portals is it democratizes the data much better than me putting it in a repository and saying, oh, you can read in this file in an esoteric format that you might be able to understand one day with a degree in computer science. I think that the portals here will be able to enable you to look at your local environment that you'll be interested in and see what the impacts of artificial light at night are. So that's been something we've been developing through this UN decade of ocean science. We've got this global ocean artificial light at night network that we're developing, and this is all part of the portal here. And really what I'd like to see is that on this excellent dark piece, not just a picture of trees here, but also the marine environment considered within the portal scale. So in summary, I think it's clear to see that there's been increases in prevalence in terms of artificial light at night impacts in the marine environment. So we're talking about 22% of global coastlines, and it is increasing. It's important that we do change to energy efficient LEDs, but actually this change in spectrum has had an unforeseen impact on the marine environment. I hope I've clearly shown that there has been widespread disruption to biodiversity patterns that you'd expect in a natural system, and also that there's been disruption to ecological strategies such as camouflage, which is changing predator-prey relationships in our shorelines. And then finally, that there's been disruption to natural cycles through the way that the artificial light is rhythmically compared with the natural environment. So finally, just to finish, I think what we would love you to do now is to share your thoughts with us. We'd really like to receive ideas from you and any other opportunities to raise awareness of this research to inspire action. Also, if you're aware of the Artificial Light at Night Atlas or research being used in any way, please let us know. And finally, we've left a little QR code there. Sorry for 2 QR codes in a presentation. Yeah, if you just scan that one in, then you should be able to get to a little survey, I think, which enables you to get involved with all of this. And then for further information, we've put together this sort of policy briefing on artificial light at night and its impact on the marine environment. So you should be able to have a look at that as well. So on that note, Chris, I shall hand back over to you.
Wonderful. Thank you very much, Tim. Great questions coming in from the chat. And if I could speak on behalf of our audience, just wonderful presentation. Learned a lot. Very interesting. Before we get to our questions, folks, thanks again for joining. We will have this recording available after our seminar today. We'll post it on our YouTube channel once able. If you do have any other questions, please do submit them via the Q&A feature or the chat portion of your screen. The first question I will take it from Wen. I see you have your hand up, so I'll just go ahead and read it from here. There are legions of fishing boats with light rigs to catch squids offshore and probably other types of fishing that's going on. They're a major source of light pollution, even in sea turtle conservations. Are there other impacts, based off what the fisheries are targeting with the light and then versus what else is being affected? Has that been studied?
Yes, so thank you very much indeed for that question. I think a really good place to start is the review article that we put together a few years ago now in terms of the documented evidence that we're gathering for impacts upon marine biodiversity. Yes, there is that direct impact upon the stuff that you can see. So yeah, the fish, it's been a strategy for millennia of shining lights into the ocean to attract the fish and the squid. I think the other thing that they attract are the seabirds. So we know that the seabirds, yes, in the local area are drawn in, but we also know from migration patterns of birds that wherever we put a bright light into the environment, be it marine, be it terrestrial, that you impact those migrationary sort of corridors. So it impacts upon on that. And I think the other thing that is noteworthy is the impact upon the deal vertical migration of the zooplankton. So zooplankton are the beasties that feed on the phytoplankton. So the phytoplankton, are the sort of the plants of the ocean, tiny, submicron plants in the ocean. They're fed on by the zooplankton that are slightly bigger, they're sort of about 100 micron, and they're important also for the fisheries. So it's impacting the entire food chain, not just the bits we can see, but also the bits that we can't see. Now, in terms of the impact upon things like coral broadcast spawning, I think that's much more the fixed things like our cities that are close to coral reefs. So that gives the most impact rather than just the fishing boats, which kind of come and go.
Sure. And I'm sure if you're adding anything to that environment from the bottom of the ocean all the way up, you're affecting those hunting patterns, how animals, birds are traveling. Wow, that's amazing. Are there, like Caitlin asks, are some of these broad takeaways valid for freshwater or animals too? we may not have coral in the lakes where she lives, but a plethora of other essential freshwater life.
Yes, absolutely. It's something I haven't done so much work on myself, but there are groups within Europe who I'm working or who I'm working with. So the Aquaplan project that I mentioned at the very beginning, there's a few groups there in Holland and in Germany that are looking at impacts on freshwater. One thing which they're looking at are the migration patterns of fish up rivers. So particularly the sorts of fish and and eels, for example, that migrate up rivers from the marine environment all the way up river courses. Salmon, for example, as well. It's at the pinch points where you've got cities that are very brightly lit. What's the impact upon the life strategies of those migrationary species? I suspect that there's a large impact upon in the Great Lakes. So I'm thinking of Chicago, for example, which is obviously lake surround or is right on the Great Lakes there. So that will be a large impact upon a freshwater system. We've also been looking at some of the major freshwater lakes in Europe. So Lake Geneva, for example, Lake Balaton and Lake Vanern. We know that there are impacts there on those systems. I think lakes are going to be a slightly easier ask to look at
Mm.
because they're bigger. Rivers are much more episodic in terms of their flow, in terms of their optical properties, which then really governs how the light decays with depth through the water.
Interesting. Wow. Yeah. And then the way the boats that intersect with that. Very interesting. Wow. A lot of good thought starters here. Tom asks or says, I'm interested in the impact of coastal lighting, not only on marine biodiversity, but also marine transportation safety, which in the US is the province of the Coast Guard. Are you or is anyone else aware? Feel free to post in the chat of jurisdictions that have regulated coastal lighting to protect darkness.
Yes, no, I'm not aware at the moment of ways of doing that. I have some anecdotal evidence. So we've had some stakeholder meetings here in Plymouth with port authorities, and one of those anecdotal stories was that Plymouth is as a city is very hard to navigate at night because it's very brightly lit because of the dockyard here. So actually having less lighting is much better for marine navigation than actually having more, which may seem counterintuitive to most of us who live on the land. But actually having lots of bright lighting makes it very difficult to be able to see the navigation lights, for example, and see where you are.
Hmm. So back to the example of the boat or fisheries, is there a way those lights can be modified and changed to reduce artificial light at night? And two-part question, because I'm combining two of you. Couldn't the fishing lights be modified to be friendlier without directly reducing these fisheries' expected harvests?
Yes, that's an excellent question and something I haven't got a scientifically proven
Good.
answer for.
Yeah.
But I suspect that if you look at this, if there's a particular species of fish that you're looking to harvest, then actually it will have its own sort of which frequencies of light is it most sensitive to, and then if you make sure that you use those frequencies of light rather than sort of a broad brush, broadband lighting, then that might be a good strategy. I mean, I think with what we're not saying is, do away with light completely because yes, we do see that there's safety concerns, but actually, if we're just lighting because we can, we're wasting energy, we're wasting photons, all these issues. And I think we can do better, I think is always my take home message.
Absolutely. I think this crowd agrees. We can do better. Right, folks? So, yeah, Stephen adds some offshore oil rigs have used pure green lights rather than amber or broad spectrum, which supposedly does not attract as many seabirds. um, green spectrum lighting compared to red or blue in terms, I know there's other studies with moths, the only color they can't see is red. We're not changing all lights to red outside. So there is that balance, as you mentioned, between human and the bio. Um, any thoughts on that? More studies, more research we need to do.
Yeah, I mean, I think green lighting is it's not perfect, particularly where you've got very clear waters. So I didn't really go into this in any detail in the presentation, and all I said was really that pure water absorbs very strongly in the red and not very much in the blue. But actually, once you start putting constituents or the natural constituents into the water, like phytoplankton, that absorb quite strongly in the blue, not very much in the green, and then some again in the red. There's not much. If you're in an area where you've just got phytoplankton in the water and not much else, you're still going to get quite a lot of light penetration. Not so much as in the pure blue, but you will. So it's kind of a halfway house. One thing that we've been looking at is actually having LEDs that are much warmer colors. So what do I mean by warmer colors? Well, it means that rather than having 6,000 Kelvin LEDs, you go for, and this sounds counterintuitive, but stay with me. If you go to the 2,700 Kelvin LEDs, they're much warmer because they look sort of redder, orangier, more comforting, I suppose would be a better way of looking at it. And that gives you much less light intensity at the wrong wavelengths into the water. So I think that would be one thing we would suggest. Going all out for red light into the marine environment is probably a no-go because it's not really much use to us as humans to be able to see in the red end of the spectrum. So it's kind of these trade-offs.
Yeah, interesting. Andy adds also too much bright light in the ports also results in very deep shadows, which would make it harder to navigate
Absolutely.
from the human
Absolutely.
perspective.
Yeah, it's the whole contrast thing.
Very interesting. Yeah. Um, Ben asks a great question. If we could sum this up, what's the primary message you would recommend, you know, outreach institutes give marine and light pollution?
Yeah. Well, thank you. Thank you for that open door. If you go to the presentation, we've got this sort of policy briefing, which are the things that we would really like to, or we're not really advocating because we're not allowed to advocate, but in terms of what our recommendations would be to policymakers. I mean, I think the first thing is, oh, light smart. Don't light where you don't need to. Don't, and that involves shading your lighting so that it just goes in the area you need it to. The thing which is giving us this far field effect with artificial light at night in the marine environment is the sky glow. It is that component which is giving you light 20, 30 kilometers offshore, which is then reflecting down into the ocean. And because there are so many, or particularly the zooplankton that are so low light adapted, that disrupts their biology. So it's that's giving it, the far field effect. So if we can minimize the amount of sky glow, which means the if we can reduce that amount of light which goes up into space, which then gets reflected down, that would be the first thing. I think tuning our lights. So we've talked about that looking at what frequencies rather than having very broad band LEDs which impact right across the electromagnetic or the optical or electromagnetic spectrum. Looking at tuning those lights and then sort of reducing sort of the intensity of them. I think those are the kind of strategies that
Sure.
we would go for.
That's interesting. I'm thinking
And
about the colder areas of the world and the way sky glow bounces between the clouds and the
yeah,
snow and frozen lake. There's things under there, but you're pushing this light so much further as well
sure.
during colder months. Yeah.
And can I just, there's one more thing I think, Chris, is also, turning off lights when we don't need them. And, we have the technology now. Well, arguably my dad would always say to me, turn off the light because it's expensive, when I was a kid, and they kind of drummed that into me. But the other thing is we've got technologies now to just light the areas that it's needed. You know, the Google Analytics, all these kind of AI technologies that are coming online, these kind of things we should harness to be able to just light where we need when we need it.
Hmm. Absolutely.
Our
We
dads
just
were all
need
correct, Thomas. Thank you.
yeah.
Always. Now I'm a dad myself, so yes, I know.
As a dad, I agree with that one. Yeah. Babak asks an interesting question. Are any studies, or do you know, Tim, are any studies being done on artificial light at night's impact on the glow-in-the-dark marine species, especially in shallow waters such as sea fireflies?
Um, I haven't got an answer to that. Sounds fantastically interesting. I have toyed with looking at bioluminescence as an impact, so maybe that'll be a direction that I go in next. But
I'm
yeah,
sure Babak
very
has
good,
some cool trip planned next. You could tag along. You too, feel free
fantastic. Yeah, please, please, please contact me.
please take me on your interesting trips. Very cool. Um, Here's another one from Miles. So, in regards to the species that rely on cues from our lunar photocycle, for example, the dark potential well between dusk and moonrise, do we know um, the measurement of artificial light at night sufficient to disrupt these cues? In the figure you showed, it looks like artificial light at night irradiances were a fraction of the lunar irradiance. New words. I love it. Thanks, team. Go ahead, Tim.
Yes, it's likely that they are. So we a lot of what we've proved there in that publication is it's statistically proven, and we haven't gone in and quantified, what that the number of photons or the energy that's being received in the system. We haven't gone to that level. It's been much more it's almost a presence absence type of thing. A lot of biology is done, particularly field biology is done in that basis of saying there's artificial light pollution in the environment, so therefore that's our light naive site, and that was kind of what we used. I think actually you're absolutely, the question is absolutely right. If we need to look at what those levels would be, um, what are the milliwatts or microwatts per square meter that are preventing that, and then actually once we know that number, maybe that's then a strategy for ameliorating the impact on coral in the areas where we've currently got a lot of artificial light pollution. So yeah, great question.
That's a great question. Wow. Yeah. Let's see. I'll do a few more questions, folks. So if you do have anything else, please feel free to send it in via the Q&A or chat. Tom's curious, do you know, Tim, or anyone on the call, is anyone doing research on the impact of marine lighting in coastal estuary areas?
Uh, yeah, well, kind of yes. In Plymouth, we definitely are
Yeah.
because we're on an estuary. In fact, our very first publication that Tom and I, or Tom had been publishing much more before I was. But I suppose it was about 2017, we had a paper, no, 2020, sorry, we had a paper looking at Plymouth Sound and estuary. We actually had a very good piece of field work up the estuary, and we were able to look at how much of the artificial light actually made it all the way through the water and to the river or the estuary bed. So there's a little bit of work. I don't think there's a whole big body of literature on it, but yeah, we've done some research in that area for sure.
That's interesting. Now, this more of a basic question, but I want to make sure I have a talking point to bring up, a well-rounded conversation about light pollution. What are the impacts of light pollution and marine environments? If we're in an elevator together, what's
Yeah.
your pick?
So in terms of impacts on biodiversity, if it affects the rhythms of life, it impacts the way that biology sees what it needs to eat and whether or not it's going to be eaten. And then it also sort of impacts upon the whole food web all the way through from phytoplankton, zooplankton, to the fish, and then to the creatures that are in the air as well.
Very interesting. I just came to mind the way technology has changed humankind. Let's think about how technology has impacted marine kind, right?
Yes.
Those impacts. And maybe it's too late to turn back some of the clock for this, but I'm glad we still have 150 people on the call willing to learn and hopefully get out there and make a difference. Yeah. Just a few more questions. And a reminder, we will have this posted to our YouTube later in the week if you did miss a part or want to catch up again, or share it with a friend. We have another question from Michael, DarkSky Michael. Are there specific species of corals affected by light pollution more so than others? Soft corals versus small polyp corals? Or how does light pollution affect the diversity of coral life?
Wow, that's a really great question to ask a non-coral specialist. So, Michael, if I could direct you towards the Nature Communications paper that we have published, we did look at several different species of coral. I don't think we really had enough data to look at, to disentangle the impacts upon the different species, and then also to discriminate between the soft versus the small polyp corals, and then to go to the light level of how does it affect the diversity of corals. There are several groups in the world who are looking at corals. Corals are very popular for marine biologists, as you can imagine, because you get to go to some of the most beautiful places in the world and dive in warm places, unlike off Plymouth, for example. But there may be some information that you're looking for in that paper. So the link will be in the presentation, and I'm sure we'll make the presentation available to people after
That's
this.
great. And Tim, if people do have questions as a follow-up to this, what's the best way for our folks to get in contact with your folks?
Email me, I think, is the best way. So Chris, you've got my email.
Yeah.
Or in fact, I can put my email in the chat, and then you've got that. So
Great.
just putting that there.
Great. Thank you, Tim. Yeah, folks, we will be closing up soon. Mary, we'll get to your question in one moment. So I'll have you come off mute. And Tim, just thanks again for joining us and providing this learning opportunity to all our DarkSky fans out there. There's even more questions coming in. So folks, if you did have something still, feel free to post it. We'll get it over to Tim, or feel free to contact us or him directly. Thanks again. Mary, did you want to come off mute to ask your question to Tim?
Really quickly. I am particularly interested. Am I off mute?
You can hear you.
I'm particularly interested too on the effect of human life. I mean, I certainly see something like menstrual cycles, which radically changed as light changed, and the effects of that. And more important is, how do I get this message out? I became a Pachamama facilitator. I'm talking to people, they're nodding in the audience. That's not the people I want to talk to. So how do I, in my everyday, look for strategies to be able to bring this topic up? And thank you for my question, taking it.
I mean, I could take the first half of that, Tim, because that's what we do here at DarkSky. We're focused on the advocacy. I'd say, it starts with a well-rounded conversation, but honestly, it comes down to who else you have supporting, driving that type of conversation with the decision makers you're trying to approach. My local chapter, we focus on public awareness of light pollution, problems and solutions, policy conversations, and our partnerships. So broadening that message. That's, of course, really supportive of our DarkSky preservation and those programs like DarkSky Places, or maybe an eventual marine designation like Tim was talking about. So being able to meet the people while we're that, and if you're talking specifically to policy folks, help them do their job. So providing them templates, those talking points, so they can look smart to their boss and get your work done for you. So I'd be happy to talk more about that, and really to anybody as well. Feel free to reach out to us at DarkSky. We can help you along your advocacy journey. So Tim, final thoughts?
Yes, am I off? Yes, I am off mute. Thank you, Mary. Yes, that it's a really difficult question to answer in a very succinct way, and I think what one thing that I've learned is really this subject grabs people's imagination, and I think it's because they can see it every night over the cities. As soon as you point out, there that shouldn't look like that, or okay, it's always looked that way, or it's getting worse. That kind of it's something that they can really relate to, much more than a lot of the global the ways in which we're pushing the planet out of kilter. So in terms of the oceans, ocean acidification, climate change, all these issues are really hard for people to to telescope right back down to the individual level. Whereas I think with this subject here, we've got something that people can relate to on a personal level. And it's almost as if they can see that they can do something about it as well. So that's at the kind of the individual level. I think what I like about this also is that it's particularly in the United Kingdom, it's kind of going up the agenda. It's gone up the political agenda, certainly. So the legislators and sort of we've got two chambers in the UK. So we've got the House of Commons, we've got the House of Lords. The House of Lords recently had what the impacts of artificial light are on human health. This is something that they are aware of, and they know that there's something they can do about. And I've also given presentations at the Houses of Parliament on to their people who are looking at the dark skies. That's one thing that they're interested in doing. So we do have a way of talking to the people that make policy and make a difference. So I think there's a kind of a two-pronged way of doing things. At the individual level, yes, and I think it's something that people can latch onto quite quickly, and they can kind of get quite quickly, not just at sort of people who don't do science, but also scientists. It's amazing how much within the laboratory here, it's grabbed the scientists' imagination as well as something that's quite visual, and that's something we can do something about. And then sort of at that governmental level, I think that's something that we can address too, and we got sort of the right ways of talking to people there.
Wonderful. Well, great insight, Professor Tim. Thank you so much for joining us. And folks, thanks again for attending today. If you want to send this video out to a friend, we'll have the YouTube link coming to you shortly. Make sure you're following us. Stay tuned for the next talk that we have. Tim, thanks again. Again, great presentation. Really looking forward to sharing this message of marine life and impacts on it. So thank you. Thank you, everybody.
Brilliant. Thank you very much indeed.
Thanks, folks. We'll talk to you soon.